Hi guys, today we're going to see about C data types. Here first of all, data types in C refers to a large system which is mainly used to declare variables or functions of different types. So the type of a variable tells us how much space it occupies and how the bit pattern stored is interpreted. So in C programming, variables and memory location should be declared before it is used. It implies same to the functions as well. Even a function needs to be declared before it is used. So, data type simply refers to the type and size of data which is associated with variables and functions. So, here's a brief explanation about C data types. C data types are defined as the data storage format that a variable can store a data to perform a specific operation. Data types are used to define a variable before to use in a program. Size of a variable, constant, and an array are determined by the data types. So next we are going to learn about different types of data types and its description. Here there are 4 different types of data types: basic type, enumerated type, type void, and derived type. Basic type is arithmetic type, which is divided into 2: integer type and floating point type. Second is enumerated type. These are also arithmetic types. They are used to define variables that can only assign discrete integer values throughout the program. Next is type void. The type void indicates that no value is available. Next, derived types are classified into 5: pointer types, array types, structure types, union types, and function types. So here let's go in detail with the different types of data types. First is integer data type. Integer data types are whole numbers which can be both positive and negative values but no decimal values. So your example is 0, -5, 10, etc. So the keyword int is used for declaring an integer variable. Example, int id. Here id is a variable of type integer. Next is you can declare multiple variables at once in C programming. So example here is int id comma age. You can declare as many as you want depending on the program. Here example is int id comma age. Here id and age are 2 different variables of the type int. So next here the size of integer is either 2 bytes. It depends on the PC. It is 2 bytes in new computer and it is 4 in old computers. So if you consider an integer of the size 4 bytes, which is equal to 32 bits. 4 bytes is 32 bits. So that means it can have 2 to the power of 32 distinct states. So similarly, if it is 2 bytes, it is 2 to the power of 16 different states. So if you that is which is from -2 to the power of 15 to 2 to the power of 15 minus 1. So many different states you can have. So suppose you try to store a value which is less than -2 to the power of 15 or which is greater than 2 to the power of 15 minus 1, then your program won't run. So let's conclude. Integer type, a data type, allows a variable to store a numeric value. Int keyword is used to refer integer data type. Storage size of int data type is 2 or 4 or 8 byte depending on the PCs. Suppose if you're using a 16-bit processor, 2 byte of memory will be allocated for int. It is the same if you're using a 32-bit processor, it is 4 byte, and if you're using a 64-bit, it is 8 byte. So if you want to use integer value that is crosses the above limit, then you could use long int, long int, for which the limits are very high. So next we are going to learn about floating types. Floating types hold real numbers. Example 3.4, minus 9.382, anything, etc. So you can declare a floating point variable using float or double keyword. So here example is float account balance, float book price. Here account balance, book price are variable names which is of the type float and double. So in C you can tell floating point is also used for representing exponential form. Here example is float normalization factor is equal to 22.442e2. Here normalization factor is a variable which is of the type float and has the value 22.442e2. So next here the table shows us about the floating point types with their sizes and the ranges and their precision. So here header file float.h defines macros that allows to use 3 values and other detailed about the binary representation of real number in your program. Macros is a function. So without this float.h you can't represent any real numbers. It will throw out an error to you. Only because of float.h it allows you to use these values and other details about representing the primary binary representation of real numbers in your programs. Otherwise it's going to throw out an error to you. So here float, the size is 4 byte. So it ranges from 1.2e minus 38 to 3.4e plus 38. So it can go up to 6 decimal places. Double is 8 byte. This is a range 2.3e minus 308 to 1.7e plus 308, and it can go up to 15 decimal places. Long double is 4 byte, which is 3.4e minus 4932 to 1.1e plus 4932. So this can go up to 19 decimal places. So conclusion is floating point data type is 2 bytes, float and double. So float type allows a variable to store decimal values. Storage size of float is 4 and it varies depending on the processor in the CPU, which is same as the int data type. So we can use up to 6 digits after decimal when you're using float data type. Next, double. Double is also same as float data type, but it allows up to 10 digits after decimal. So here you're gonna see about character data type. So character data type keyword is char, char, for declaring character type variables. So example, char test is equal to h. Here test is of the type char and the value is h. And the size of a character variable is 1 byte. So next we're going to talk about void type. Here void type is nothing but it's an empty data type that has no value. This can be used in function and pointers. So here there are different types and its description. That is, there are 3 different types: functions returns as void, function argument as void, pointers to void. So here a function, the first one, a function with no return value has a return type as void. Here does not return anything, so the return type will be void. This is an example. Next, function arguments as void. when a function with no parameter, it can accept a void. See here, int, ran, void. Here you're not accepting any parameters, so it accepts an void. Pointers to void. Here, pointer to void means it gives the address of an object but not the type of an object, which type it does not tell. So here, example, memory location function, that is void star malloc size underscore t size. It returns a pointer to void which can be casted to any data type. So here enumeration, we're going to see about enumeration data type. Enumeration data type consists of named integer constant as a list. So here the list starts from 0 by default and the value has been incremented by 1 for the sequential identifiers in the list. So the syntax of enum is the keyword, which is the identifier, and enum list. Example, enum month Jan, Feb, March. Here Jan, Feb and March variables will be assigned to 0, 1, 2 by default. In the second line, enum month Jan is equal to 1, Feb, March. Here what happens is Feb and March variables will be assigned to 2 and 3 respectively by default. The third example, enum month Jan is equal to 20, Feb, March. Here Jan is assigned to 20, so Feb and March variables will be assigned to 21, 22 again by default. So here the above enum functionality can be implemented by #define processor directive as given below. Above enum example is same as the given below. So here #define Jan 20, #define Feb 21, #define March 22. It is same as the above enum month, open the bracket, Jan is equal to 20, Feb, comma, March. So here size of function in C language. Size of function is nothing but to find the memory space located for each data type. So if you want to find how much data type storage is taken in your system, and see, let's type this program. Open your code blocks. So first integer int a, and then character b, float c, double d, and then printf. Storage size of in data type is mod d \n and use the size of operator. Size of what? Integer. Integer is what here? It is a. So size of a, semicolon. Repeat this for everything. For char, float and double. Copy it. Here just change the int to float or character data type, and then size of character, which character has b, so size of b. Float. See here, double d. Return 0. Save it, build and compile it. Build and run it. See here, my size of int data type is 4, character data type is 1, float data type size is 4, double data type is 8. So it might vary for different CPU processors, as I told earlier. So next we are gonna read about modifiers in C. So the amount of memory space to be located for a variable, it is derived by the modifiers. So suppose you want to change or increase or decrease the storage for a particular variable, you can prefix a modifiers with the database to modify, to increase or decrease the storage space allocated to a particular variable. So here example, storage space for int is 4 byte for a 32-bit processor. So we can increase it by using long int, which is 8 byte, or we can decrease it using short int, which is 2 byte. So here are the different types, different modifiers: short, long, signed, unsigned, long. So when you talk about short in general in data type occupies different memory spaces for different operating systems. So to allocate fixed memory space, we use short keyword. Next, long. This can be used to increase size of the current data type to more bytes. This can be applied to both int or double data types. Next is signed. Signed is nothing but the keyword accepts both negative and positive values, and this is default property or data type modifiers for every data type. Next is unsigned. This is used to make the accepting values of a data type is a positive data type. So that's all. These are the basic modifiers. I hope you guys have understood. So here it is just a brief image of the type, storage size and value range. Just take a look at it. So guys, I hope you guys have understood and what I've thought. If you liked it, please like and subscribe. Bye.